Have you ever accidentally swallowed a mouthful of seawater at the beach and wondered, why is the ocean so salty? Well, the answer is a fascinating journey that starts way up in the clouds. It all begins with rain. Rainwater isn't just pure H2O. It's slightly acidic because it absorbs carbon dioxide from the atmosphere. When this slightly acidic rain falls on land, it acts like a very slow, gentle chemical agent, breaking down rocks. This process is called weathering. As the rocks erode, they release their mineral salts, which then dissolve into the water. So now we have this water on land, filled with dissolved salts. What happens next? These tiny streams and trickles of water flow into larger rivers. Rivers are like the planet's conveyor belts, constantly flowing from the land towards the sea. As they travel, they carry all those dissolved salts and minerals with them on a one-way trip to the ocean. For millions and millions of years, rivers have been dumping this salty payload into the ocean, causing the salt to gradually accumulate. But wait, if rivers are constantly adding fresh water, why doesn't the ocean just get diluted? This is where the sun comes in. The sun's heat causes water from the ocean's surface to evaporate, turning it into vapor and forming clouds. This is the water cycle in action. But here's the key. When the water evaporates, it leaves all the salt behind. Imagine boiling a pot of salt water on your stove. The water turns to steam, but the salt stays in the pot. The same thing happens with the ocean on a massive scale. This constant process of evaporation concentrates the salt, making the ocean saltier over time. There's another source of salt too, and it's a bit more dramatic. It comes from deep beneath the waves. All over the ocean floor, there are hydrothermal vents and underwater volcanoes. Think of them as hot springs on the seabed. They spew out superheated water that's rich in dissolved minerals and chemicals directly from the Earth's crust. This adds another dose of salt to the seawater, contributing to its overall salinity. This might lead you to another question. Why aren't lakes as salty as the ocean? Most lakes have both an inlet and an outlet. Rivers bring in a small amount of salt, but other rivers or streams carry it out. So the salt doesn't have a chance to build up. The ocean, on the other hand, is like a giant basin. Water can only leave it through evaporation, which, as we know, leaves the salt behind. Lakes have a way to flush out salt. Oceans don't. That's why some lakes, like the Great Salt Lake or the Dead Sea, which don't have an outlet, are incredibly salty, even saltier than the ocean. So, has the ocean always been this salty? For the most part, yes. The ocean's salinity has been pretty stable for hundreds of millions of years. The amount of salt being added by rivers and underwater vents is roughly balanced by the amount of salt being removed through other natural processes, like forming new minerals on the seafloor. On average, the ocean's salinity is about 3.5%. That means in every liter of seawater, there are about 35 grams of dissolved salts. And here's a fun fact to put that into perspective. If you could somehow remove all the salt from all the oceans and spread it evenly over all the land on Earth, it would form a layer over 500 feet thick. That's as tall as a 40-story office building. This salt is also the reason why it's easier to float in the ocean than in a freshwater pool. The dissolved salt makes the water denser, which gives you more buoyancy. So the next time you're at the beach, you'll know that the salty taste of the ocean is the result of an incredible, ancient cycle involving rain, rocks, rivers, and the sun. It's a process that has been shaping our planet for billions of years. Thanks for watching. If you found this interesting, don't forget to like this video and subscribe to our channel for more amazing science facts. See you in the next one.